Hello and welcome to another episode of the Measurement Lab. Today I am joined by Akash Bhakta, one of our senior members of LabVIEW R&D. Akash, how long have you been with NI?
But 21 years.
21 years. So what version of LabVIEW would you first joined us with?
So I first started working on LabVIEW 8.0 when I was a software intern. Then towards the end of the internship, we had my feature moved backwards to LabVIEW 7.1. That was not, sorry, LabVIEW 7.0 Express. That was not out yet. So it's actually LabVIEW 7 Express was my first LabVIEW I worked on.
Okay, that's the first version that you contributed to in some way.
Yes.
Okay, I gotcha. Yeah, I was going to say, because if you joined 21 years ago, that would have been in the midst of actually developing 8.0, which makes sense. And obviously from your shirt, I gather you went to school here in town, UT.
Yes.
What was your degree at UT?
It was computer science.
Okay, makes sense.
Yeah.
Great year to be a UT fan with them on top in football. But awesome. So computer science, and it makes sense given that you're working in the underpinnings of LabVIEW. Leaving school and throughout your career at NI, what's the primary language you've done most of your work in?
Most of my work has been in C++. A little bit of Python, but mostly C++ and G itself.
Okay.
So you have LabVIEW, it's a programming language where some of our features are written in G. So those two.
And the bulk of what happens under the hood with LabVIEW and the work that you do is, especially when we talk about compiler and whatnot, that's C++ code.
Correct. That's C++ code. The LabVIEW executable, we come to C++ code, we build it and creates that LabVIEW.exe.
Which I should explain, there's a lot of things you've worked on, and maybe we'll have you back, but at least for this discussion, we wanted to zoom in on your time spent working on Application Builder. And I think that's something that most every LabVIEW programmer interacts with on a regular basis. But just to set the stage, can you walk us through what Application Builder does? How does it transform LabVIEW source code into compiled binaries?
Right. So the output of the app builder is to produce binaries. Most traditionally the executable, and then we also have a LabVIEW build DLL, a pack project library, source distribution. So it produces those things from your source code, from the VIs and libraries, and a project. So those are the inputs to app builder. It takes a project with your source code in it, VIs, libraries, and a build spec. So underneath a project, you must have a project, and the target, there's a build specification there. That build specification is the recipe that is used, that specification of how to build the binary. So what type it is, obviously, that's the first and foremost thing. What is an exe or pack project library or DLL? And then what are the VIs, the top level VI that's in there that's supposed to be the top level, the executable, or your exported members of it, if it's a pack project library, those sorts of things.
Right. So you need all these input. You feed it to App Builder and just it spits out a beautiful binary. And we'll get into some of the details of how it works and some of the complexities. But I guess before we get too far from it, we just mentioned that you work in both LabVIEW code as well as C++. You mentioned Python too. What is App Builder predominantly written in?
Predominantly written, it's C++. But then when you look at the product, when you install it, you only see it in one file. I mean, several files, but most of them are VIs themselves. So our lab, virtual instruments themselves.
So it's a mix of C++ code and is it actual LabVIEW VIs or VIs that have been compiled into binaries?
Those are VIs, just regular VIs. So they're source code VIs. So they can be used as, like the VI lib, for example. Those are like equivalent of like C++ as a standard template library. There's already code written there. There are useful things that when you interact, we have sub VIs that are already written. They do common operations. Many of those are all in the distribution themselves. So the product itself, it's mixture of both. It's what C++ is used to build the editor and the compiler and such, but part of the editor and the user experience is pre-written VIs.
Well, and those VIs too, I mean, I'm assuming when we distribute functionality, it's actually written in LabVIEW. We distribute those VIs as source only, so we don't have to compile for the various targets. Is that the case with Application Builder?
Okay, so yes, so we ship the raw, just the source only VIs, but we also pre-populate object code for those. We don't populate all the object code. So if you're selling for Windows, you won't get the object code for Linux or those things already targeted built. So if you use Application Builder, it will produce a binary or source distribution
Okay.
targeted for specific platform.
So there is some object cache that's installed with all the, I guess, universal assemblies, and then everything else is platform specific. So makes sense. I guess to see this next question, I've interacted with my fair share of programmers or users who mistakenly believe that LabVIEW is not even compiled, right? They assume it's interpreted. And I guess that's just implied because often there's not an explicit compile step, at least when interacting with the editor. Is that the most common myth you've encountered? I mean, I guess I want to set you up to say, what are some of the common myths or misconceptions you've encountered when working with customers, especially with regards to Application Builder and how it works?
Well, like regarding it being a standalone application, does it produce a standalone application? And so the answer is like, no, it doesn't. It's not a standalone application because we need the LabVIEW runtime engine to, load the VIs. It's essentially LabVIEW, and the inside the binaries are still VIs. They're still VIs written there. They may be in different formats. Depending on the build specification, we have an option to do a fast file format. And in that situation, that the VIs are they're very different to the VIs you see on disk. But if you don't use that fast file format, and in very older versions of LabVIEW, you would have just basically VIs in a zip file, you can imagine. And then
Oh, really?
the runtime engine would just look at that file, pick the top level VI, and then open it and run it. And so
it really becomes a tool for like packaging. I guess, historically VIs contain both the source and the binaries. I know now we recommend everybody work in source only, but if you go back to that era, it's like, well, you effectively do work to generate the binaries and you're just taking that and repackaging it. Correct me if I'm wrong. There was a time when the output of App Builder actually didn't require a runtime. Is that true, or has that always been the case?
That's probably going back before my time. I don't remember that, but I can imagine. I can imagine that to definitely work. I mean, it's just a matter of what we save. So most time, like an executable, even in the old days, we would strip off. Like we would remove from panels and block diagrams. For a lot of the sub VIs, with the top level, we'll still remove the diagram but keep the front panel. So it's a lot of removing, but it's still the same VI. So if we just didn't do that and had the ability to load, it should probably still work because it's an LLB before it was in a different format.
So then if we have all these different targets, right? You mentioned some. There's LBs, more modern technologies, or PPLs, but of course there's DLLs, what else? .NET assemblies, of course executables. Like, how different are the internals of those formats? Are they fundamentally the same with different like wrappers, or are they dramatically different? Is the work that App Builder does significantly different?
There's different work to get them into that binary, but they're kind of similar. So the executable and the pack project library, they're both like, if you build them both if you build the executable in fast file format, it'll be in the leaf format. The difference is like how it loads in the runtime. It would pick the expected top level VI to be there. There's essentially I wouldn't say, like, long story short, it's similar but not the same. I'll say the more very, very similar, but
okay,
yeah,
makes sense. So then, given that we already have this tool chain that's doing the type propagation, the linker, the compiler, and that generates our binaries. Walk us through, like, how different are those steps when we give it to Application Builder? Right? Is it fundamentally just doing the exact same things, or are things that are done differently? And I, put this in terms of a user who cares about, I want to make sure my application works the same, that the behavior is as expected in the development environment. Like, what do we need to be mindful of when transitioning from the dev experience of clicking the run arrow to actually a production system that's running a built binary?
Right. So, app builder. So, like when you have all your code compiled in the IDE and working, it's it feels like the application is already there. We would just have to package the VIs. So that was kind of like an early idea, but overall, through all the years, new features come into the build spec, and some users want additional changes being made to the source while you build the executable. For example, the option to disconnect type defs, or to remove unused members of libraries, to remove unused poly instance VIs. These are like compile optimizations to reduce the size of the code, to hopefully make it run faster or load faster. So those are steps required in between. You already have your code working in the IDE and you want to make it executable. App Builder will go through and make all these transformations and then compile and then save. So there are a lot of steps to get to there, and all this is written. Like the back end of App Builder is essentially VI scripting on top of some private VI server methods, some public, some private on top. So it's a layer on the editor to make those modifications for you, like disconnect type defs. That's a public VI server method. I think it's public.
Okay. So let me understand there. If you're saying most of it is VI scripting, which makes sense, right? It's repackaging, stripping stuff out, probably modifying namespaces, etc. So are the methods that it's using predominantly public, such that somebody else could go effectively recreate application builder if they wanted to waste that time and energy? So that is to say, duplicate.
In theory, yes, but there are also some tight coupling to the actual back end of the C++ compiler that will be difficult to write it without opening up more things.
Okay.
Yeah.
So what are some of the common mistakes that you see people really struggle with App Builder? And for anyone watching this, I want them to hopefully leave with some nuggets of like, I should do this or not do this to avoid some of the common pitfalls you've seen people struggle with when trying to use App Builder.
Maybe they're not really mistakes, because we provide the options to the user, so they should help. But in terms of
we give them rope, right? We give them plenty of rope, but no, I think knowing when to use those options is half the battle. Sorry, finish your thought.
Right. So say in newer versions of LabVIEW, like 23 and later, like if you just go to the additional exclusions page and just exclude the maximum you can, that creates less things to process. So we know ahead of time that you're disconnecting all these unused members. The user specified to remove all these disconnect member VIs, type defs, unused things. Then that creates a faster build because there's less items to do work on.
So that's interesting, because I figured we would, when you specify what's included, I would expect we traverse the tree and say, okay, here's the dependencies. You're saying, though, that if you explicitly tell it what's not included, that decreases the time spent evaluating what actually needs to be included?
Oh, it decreases the time of actually compiling and saving. Processing, compiling, and then saving into the binary, because there's less VIs in the end to do that.
Those VIs shouldn't be included if they aren't a dependency, unless it's loading a library, which then would by default bring in all the dependencies. Is that onto something? Or
right. Yes, you have a library that has lots of VIs, but you're only using 2 of them. So we want to remove all those. Whereas they could be, as opposed to be, if you include all of them, then they get loaded, and then you've also
But if you let's take an example of, like, I'm going to pick on AAL because I think that's a pretty large library, and it's probably pretty common that you just use one specific member VI of that library. So great, you just use that one member VI. By default, it will pull in the entirety of that library. And I think part of the reason is maybe it's being used in an application where somebody else needs, a different VI from that same library, now you're ensuring that you have one, I'm going to use the word singleton, but like you're sure that it's in that container. I guess the risk is if you exclude the other stuff and yet you have some way of later on needing something from that same library, it won't find it.
Right. So this, you can run into those, I guess those are issues of namespacing. You say you built a source distribution in your class, or your library has been reduced to the VIs that it needs, some subset of a library, and so that library only has 4 items, and then you combine it with some other, you load some plugin that also uses a VI from that same library. Now that VI is already loaded in memory, and it doesn't reciprocate. So,
but you said the key word. That's only going to be an issue with the plugin, which implies there's not a static explicit dependency. It's dynamically loaded at runtime. So it wouldn't have had a way to have known that thing was needed. So maybe we went down a rabbit hole. I think it's interesting, but like if everything's statically linked, then exclude the stuff you don't want and build times get faster. That's like the punchline of
right,
your advice.
Right. There's been a little bit of an inflection point, because if you say, exclude everything. So if you exclude type defs, when you start disconnecting type defs from VIs, that actually forces a need to compile. So you are going to get that compile time, but you also get less type defs. So you get less type defs in your thing. So it's one of those.
So if you exclude a type def, then it has to basically inline that as a data structure in the VI.
So disconnect type defs, that's a right click. You can right click on any type def on front panel, or even maybe front panel. Right click and says disconnect type defs. That is a VI server API for that, and so that's what app builder is doing to all the controls that are on all the VIs. If it's connected to a type def, just right click disconnect type def. So now the VI is.
Why does app builder do that? Or it only does that if you specify to exclude the type def?
Yes. It only does it if you specify. But I was just saying earlier that was like something to recommend doing, just to keep it smaller. And
no, that's good. I'm learning. I didn't realize that. And I think it further underscores the extent to which VI server is what makes app builder tick. Okay. So, all right. So try to minimize. I mean, especially if you care about the amount of time it takes to build, minimize the stuff that it has to build. Makes perfect sense. Be mindful of discounting type defs, because then there's potentially more work needed for every VI that would have used that type def that is still included. What else? Like for example, there's a lot of debugging options built into App Builder. Do they really make a difference? And like, when should a user be mindful of turning those off?
Turning those off. Well,
including like front panels and sub VIs are not included by default, or they are?
Front panels they're not included. Only on the top level VI. If it's an executable, the top level items will be there. And if it's a pack project libraries, there's an idea of multiple top levels. Even in executables, there's multiple top levels, but PPL is multiple, and that is the public export of the library. So the library is an import, and the public scope is actually the export list. So all those will have their front panels, because you should be able to load that pack project library into a project and click on the
makes sense.
Yeah, and see the panel.
Yeah, it makes perfect sense.
Okay, so includes the diagrams. Yeah.
Okay, and how much of a difference does that really make? Like, can I just always include my block diagrams just in case, or is that actually going to have a substantive impact on my build binaries performance?
So it should not affect the load time performance of a pack project library, because we're not supposed to load the diagrams unless the user, literally you go in there and hit Control E on some VI, then you have but if you were to accidentally maybe keep them open and then you start running your code, this slows down execution time if you have we call them heaps in memory, the front panels and diagrams in memory. Because even if you're not looking, if you just minimize the panels, we still update the controls and indicators, and that takes time. So if we only not do it if it's unloaded, so not in memory.
Are there any other things that you're actively working on with regards to application builder that people, when it comes to the future?
We're working on just performance improvements, so just making it build faster, um, and like this is app builder cache that we've introduced in LabVIEW 2011, and it saves the compile step. Um, but now we just save more, so we expanded the scope of this app builder of the cache, so it skips more steps than it did before. And it applies to more build spec types, and it changes the algorithm a little bit. Like all the detailed steps that we have, all the VI server methods they're a little bit different, and we feel they're better, more efficient. So we remove the concept of renaming and namespacing. There's other tricks that we've done under the hood to automatically rename. So we would just like when we load VIs into like this build application instance we use internally, we would automatically give them the new names, and then and their dependencies. They would automatically just so there's no renaming. So in the old app builder, what we used to just call file set path, to change its name, and that causes a ripple effect, and we have to manage that ripple effect. Those are performance issues we were working on since like 2012 through 2018.
So that would kick off like a whole like if you rename a VI, doesn't that kick off like basically the entirety of the compile tool chain?
Well, the first step is to just update all callers with a new name, and it could update. It could cause it need to compile. So we started separating the need to compile from. It was careful like analysis of what can we remove compile from, because compile, we should only compile when we need to compile, and then so we've were places where we would overdo it, so then we'd have to scale it back, and we decouple compiling from other sections of LabVIEW, and renaming is actually one of them as well. But I think in an ad builder, I think we have it down to like just the disconnect type deaths that causes the recompile. So I think in the future,
I know forward, I was working
if we could somehow figure that out, that we would have I think very few reasons, if not any, to compile. We could get back to the utopian build state of, I have my code in the IDE. Can we just put it into the executable?
Yeah, why does it take so long, right?
Well, exactly. That would be nice. So I think we
can get awesome.
By start removing all these extra things that need to happen.
That's great. I mean, that's actually more clarity than I even had coming into this about some of the things we're working on. I mean, it makes perfect sense. So, look for that in future versions of LabVIEW. Sounds like the Akash team have a vision for how to make the compile steps dramatically faster. And I'm thinking of a few customers, one in particular that we've been working with that has 40,000 VIs for a single application. And they have a bunch of different build specs. They've chopped it up. So I think they will be very thrilled to hear that we're doing things to make that faster. So, Akash, thank you very much. As I said, I know you work on a lot more than just app builder, and I think people will be very excited to get your perspective on classes and the design decisions and how those work. So we will have you back to talk about that. But for right now, I want to leave it here. And thank you for your time. Of course, if anyone watching has questions for Akash or wants to dig deeper into any points that were brought up, feel free to leave a comment or question below, and we'll do our best to get back to you. If you have suggestions for future topics, same thing. Leave us a comment below. And of course, as always, subscribe so you get all the updates for future measurement videos. Thank you, Akash.
All right. Thank you. All right. Bye-bye.